Hi folks, my name is Cam Vedbrat. I'm the Group Program Manager on the Windows Graphics team. Our team owns the set of DirectX APIs in Windows, and we're really the champions for PC gaming in the Windows organization. I've been working on the Windows team for over a decade, and by far I've spent the largest chunk of that time working in graphics. I'm super excited to talk to you all today about what we're building in graphics and for games for Windows. So in this session, we'll take a look at what we've seen in the game space since we launched Windows 8. We'll talk a little bit about what we've learned to make games successful in the Windows Store. And we'll go through an overview of some of the platform advances we've made for game developers in Windows 8.1. So before we start, it's worth setting some context. Why are games important as a category? Well, the first thing to realize is there's money there. And that money is growing. In fact, games are the fastest growing category in consumer entertainment from a year-over-year revenue growth perspective. How much money? $12 billion. So $12 billion have been spent by consumers on PC gaming over the last year. And that number over doubles if you include web and tablet. The audience is huge as well. There are over 1 billion people around the world playing games on the PC worldwide. So between it being a growing category, between the sheer number of dollars being huge, and the sheer volume of the audience, it's a really important place for us to be, and a really important place for you to be as game developers. When we look at games in the Windows Store, we see the same trends showing up. Games lead our top paid lists. They lead our top free lists. They really lead the entire store in terms of downloads and in terms of revenue. We believe in this category so much that we're putting our best foot forward with great content published by Microsoft Game Studios. Up here on the slides, you see a handful of screenshots for some recent games that we've published. We're also delivering really innovative new gameplay experiences like Project Spark. And we're leading by bringing our most prominent game franchise to the Windows Store with Halo: Spartan Assault. This game is really cool, and I'm going to show you a quick demo video of it, to give you a sense of what it's like. So what you saw in that video was that all of the core Halo gameplay elements, the fast-paced action, the vehicles, the weapons, the aliens, all the characters you know and love from the Halo universe, have translated incredibly well to a touch-based tablet game. The great Halo experience that everybody loves in their living room is now liberated and can go on the go. You can play waiting for your flight, waiting for a meeting to start, or you could play on your PC at home while your kids have taken over the TV. We think this really sets a great example for AAA games and gives us a real ideal for other games to follow. So putting MGS aside, there are a ton of other folks creating really, really great games for the Windows Store. And we're excited to see a huge amount of diversity in the games that are showing up. There's every different kind of genre, from arcade action on one side to casual games and puzzlers on the other end. There are all different types of developers. We've got AAA developers, we've got indie developers, and people moonlighting at home, all publishing games successfully on the Windows Store. And there's a huge diversity of business models that are showing up as well. We have free-to-play with consumables and freemium-style games. We have games that are download to own. And ad-funded games are seeing a great deal of success as well. Now, the ecosystem around games middleware has really, really spun up since we shipped as well. We announced Unity as Unity Pro as a free add-on for developers who are using Unity Pro can use Unity to publish to the Windows Store and to Windows Phone. We announced that this morning. And there's a ton of other really great commercial and open source middleware that people can use to bootstrap their game development and really get the games that they have moved into the Windows Store quickly and efficiently. All of the middleware providers on the slide that you see here have technology you can use in your Windows Store games. So to give you an idea of what the experience is that game developers are having building their games for Windows, I'm going to show you another quick video.
Windows 8 is a wonderful platform to bring your games to because it's easy to make something that people are going to want to play again and again. Tactiles is exciting and engaging with a mouse, which is how it originated. When we brought it to the Windows 8 platform, we also wanted to really take advantage of the touch surface, and we took the Mahjong tiles and we made them come to life. The touch and the response, it's exciting, it's engaging, the animations are fluid, and you're actually, instead of touching it with your mouse, you're touching it with your fingers, and it feels really natural.
On Windows 8, supporting both touch and mouse is really exactly the same thing. When we first moved to Windows 8, I was real worried that, there's so many different form factors, laptops, desktops, but you're really using one API to develop for all these devices. Your game will work, it'll scale out from outrageously huge devices down to, the Surface tablets.
With any new platform, I think you're concerned about how the platform's going to behave and what you're going to run into when you start working with it.
Cat in the Hat. Fish.
In our case, we're using DirectX and DirectWrite. Those APIs are performing flawlessly. The text always looks fantastic on all devices. There's really no fragmentation problem. You have a single OS, and it's really a joy to be able to compile, build, and have it run on all these devices without any trouble.
We know how big Windows is. I mean, it's not a new device that you don't know whether or not people are going to pick it up or not. It's the next iteration of the most popular operating system in the world.
As a developer, you can't really ignore a market that size. Be a part of millions of people playing our games. Where do I sign up?
So that was some really great feedback. We've also learned that there are a number of things we can do to make the experience better for developers who are building games for the Windows Store. There are areas we can really, really improve the experience around getting games discovered, around getting those games installed and driving revenue from them, around keeping game players engaged so they keep coming back to the game, playing, and revisiting the franchise. We found ways to improve the platform and the tools that you use to build your games. So let me start with the store. Developers have told us that they really need it to be easier for customers to discover games. And we've redesigned the store, the user interface of the store, with this in mind. When you look at the new store in Windows 8.1, the first thing you'll see is this rotating showcase of applications. In this case, Temple Run Brave is being highlighted here. On the side, there's also a personalized list of recommendations. As you drill in to different categories in the store, if you drill into the games category, that same layout persists. The home screen of the games category has another rotating showcase with a really high-resolution, beautiful preview of the game. And then all of our top paid, top free, popular lists, all the list views that we had of games in the store are also better showcases for the games that we're merchandising. You see there's higher quality previews There's more descriptive text there for each game. It's much easier for someone to take a look at it, find a game that they like, and drill in to get more detail. When they drill in to get more detail, that looks better too. In addition to the large preview that you see, there are also a list of thumbnails on the side that people can click on to rotate through the previews that you've onboarded with your game. So overall, a much nicer way for people to discover games, take a look at them, see what they're getting, and get involved. So aside from the store, we've also built support for reusable transactions in the store. We know this is a key enabler for driving revenue through consumables. We've heard from game developers that this is super important because some of them make over 60% of their revenue through consumables. This is a really big deal for them. Another valuable tool we have for helping with game discovery is the ability to cross-promote games through protocol launch. By registering a protocol for your game, you effectively create a link that you can put in other games to launch your game. So when a user clicks on that link, it'll launch your game if it's installed. If it's not installed, that link will take the user back to your game's page in the store where they can see the preview and click to buy and get playing. Once a game is installed, you still want to have your customers coming back to it over and over again. And we've heard that we need to provide more tools to keep users engaged. We think the new Start screen will really help with that. The new Start screen has larger tile sizes. And with these larger tile sizes, there's a much better opportunity to get the user's attention and drive them back to playing. Combined with the really easy-to-build notifications with Azure Mobile Services, these are a couple ways you can really drive customers back to the game, get them playing again, and keep them engaged. We've also heard that the snap view that we had in Windows 8 wasn't always big enough to create a really great gameplay experience. People would pause their games when it went into snap view. With our new window sizes in Windows 8.1, you don't have to pause anymore. There are a number of different layouts, including splitting the screen side by side, where your game can keep playing, where your players can keep playing your game while something else happens. And this is really useful for scenarios where they might play their game while they're waiting for something to happen on the desktop, or they might want to do work on the desktop while they're waiting for something to happen in the game, like having other players join in a multiplayer lobby. Finally, I want to mention the share contract. The share contract is something that we introduced in Windows 8, and it can really help you make your games go viral. Here's how it works. If a player loves your game, they can share it with their friends. They can share it through email, through social networks, and through other apps, through any app on the system that's set up to receive from the shared contract. You can set up your game to share anything. You can share screenshots, achievements, high scores, and even challenges. Most importantly, you can share a link to your page in the store so people can come back to your game, so people can discover your game when it's shared with them and get playing. This is a really big deal in terms of driving attach and revenue through social discovery. The next thing we looked at is how we can make it easier and more flexible to package and deploy games. The first thing in this area is automatic updates. With Windows 8.1, once someone has installed your game, you can rely on them always getting the latest version on their system without them having to manually go to the store and install the updates. It just happens automatically. We've also introduced a new feature called Resource Packs. With Resource Packs, what we do is we only download the right content onto the PC that is going to be, where the game is going to be played for that PC. We can separate content out by DX feature level, by DPI, so the pixel density of the screen, and by language. And what this does is it gets customers playing quickly. They get the content they need, they can get into the game. They don't have to waste any time, any bandwidth, or any storage space on content that they'll never use. Finally, we now support much larger games. Your game can be up to 24 gigs in terms of the bundle size. This is a huge step forward for enabling PC and console games to move into the store a lot more seamlessly. Now, let's talk about graphics. One thing that we hear very consistently from developers is that they would like to see us push harder and harder in terms of improving the 3D graphics capabilities of DirectX. You saw in the keynote, we introduced a new feature called Tiled Resources, and I want to go into a little more detail on this. Tiled Resources is a brand new feature that we have in D3D 11.1 in Windows 8.1. And what this feature does is it lets you render a scene that uses many gigabytes of textures with a fraction of the overhead. Building tiled resources was a really long-term investment for us. We started working on this at the beginning of Windows 8. We partnered with IHVs to make sure that hardware was ready, and when it was ready, now that it's ready, we're introducing the API. In fact, there are over 70 million GPUs around the world today that are capable of using it. And this is a huge deal in terms of bringing a new feature for rendering to a broad set of customers in a very short period of time. This feature is only available on Windows 8.1 and on next-generation consoles. And today you can start building games with this feature using our preview. To show you a little bit more about tiled resources, I'd like to invite Matt Sandy on the D3D team to come up.
Thanks, Cam. So for this next demo you're going to see, unlike the keynote where you saw standard texturing techniques using tiled resources, we're actually going to show a different approach. In this demo, provided by NVIDIA, we're actually using a tiled resource instead of for standard texturing techniques. We're using the tiled resource to represent a shadow buffer. So here we have, for example, a 16,384 by 16,384 shadow buffer. Now here we're only using about 16 megabytes of video memory. Now this is what it would look like without tiled resources. With 16 megabytes, we can create approximately a 2K by 2K shadow buffer. And it looks okay. You've got quite a bit of jaggies. You've got some shimmering effects. But if we actually apply those same 16 megabytes to the right areas to provide the right level of detail for the screen, we actually get much crisper shadows. And as you can see, the shadows here are much higher quality. Now, to create a standard shadow buffer using the same size, 16K by 16K, would require over a gigabyte of data. So you can really see how tiled resources allows you to get the detail where you need it to produce really stunning detail in games, in modern games on next-gen console and Windows 8.1. So now I'll hand it back to Cam, who will tell you about some more cutting-edge graphics features.
We're really excited about tiled resources. You saw a couple of uses of it today. You saw us using it for texturing in the keynote. You saw shadow mapping in the demo we had just now. And there are a ton of other ways that game developers will be able to take this to really improve the experience they have in their games. Aside from high-end games and high-end hardware, we're also pushing hardware innovation in the mobile space. And one important innovation that we're adding to our feature set in Windows 8.1 for mobile graphics is a feature called hardware overlays. With hardware overlays, we enable a developer to use fixed function hardware on the SoC device to scale their output rather than having to use the GPU to do that scaling. It saves energy and increases performance. I'm going to invite Bennett Sorbo on my team to come up and give you a demo.
Thanks, Cam. So in Windows 8.1, we're introducing a new set of Direct3D APIs that allow apps to take advantage of the fixed function overlay hardware that's starting to become available in many SoC platforms. And again, by moving scaling and composition work from the GPU to the fixed function overlay hardware, we're freeing up more resources in the GPU for the actual game rendering. So to demo this, we have a reference Qualcomm development kit up here. It's one of the new chips among many that supports hardware overlays. And we have a prototype version of the game Reckless Racing running on it. So switching over. The game takes advantage of hardware overlays in two really important ways. First, we use hardware overlays to perform advanced, high-quality scaling operations. So we're running the game right now, and I'm going to go on and scale down the 3D world manually, showing that hardware overlays can perform really high-scaling operations. But one of the things you'll notice is that even though we're scaling down the 3D world, the UI elements on the game remain crisp and clear, like the map in the top center or the race position for the user. And the advanced thing you can do is you can have 2 different overlay planes running at different resolutions. The 3D world can be scaled down to save on GPU resources for the really expensive, hard-to-render 3D content, while you can render the cheap, easy-to-render, but visually important 2D content to the top plane. So Reckless Racing was able to take their existing game, and move it to the new overlay APIs, showing that these APIs can be used by existing apps, and it's really easy to take advantage of this functionality. We think it's a great way to get the best of both worlds for high quality, really important 2D graphics while saving GPU resources and maintaining a consistent frame rate for the 3D content. And with that, I'll hand it back over to Cam.
Thanks. So hardware overlays. One great thing about this feature is that it really is scalable in terms of how a developer can use it. The simplest thing to do is just use it for static scaling. Take your output, scale it up. You can scale dynamically, as Bennett demonstrated. And you can compose 2 different bits of content. One that's rendered at high resolution with all the best detail for things like a heads-up display, and another that gets scaled dynamically that has the content in the background. This can get, depending on what you need, this can get you a good deal of value for not a lot of work. The next thing I'll talk about in the graphics platform is HLSL. Developers have told us that they want to see more flexibility in how HLSL gets used in their code. And the first thing we're doing to improve that is we're introducing a new feature called HLSL shader linking. With HLSL shader linking, what you can do is you can take bits of your shader programs and compile them offline, effectively into object code. And then those offline compiled bits can be linked together at runtime when you do your rendering. This helps in a whole bunch of different ways. First, it improves performance. Rather than having to compile a lot more code than you need to when you load your scene, you can just link things together, and that takes a lot less time. The compilation process, because it happens offline, can be a lot more well optimized. It might take a little longer in the build step, but it gets people playing faster and keeps them playing longer. It can reduce code complexity. How many of us have built shader programs that are really long with a switch statement in them that basically have to turn on bits and pieces of them as they're executing in order to get the right output at the right time? With HLSL shader linking, you don't have to do that anymore. And finally, it makes transitioning code that was designed for the D3D9 fixed function pipeline a lot easier, because you can take the individual pieces of the shader programs that you use to replace the fixed function usage and link them together to render your scene. Now, we think shader linking is really great, but we also understand that there are still some scenarios that call for runtime compilation. And now in Windows 8.1, you can actually do runtime compilation in Windows Store games as well. This is really, really valuable because it provides a very short path for taking existing desktop code bases that use runtime compilation and bringing them into the Windows Store. I encourage you to give both of these a try. Now, we've also seen a ton of developers experience a great deal of success using XAML and DirectX together. XAML is a really powerful tool for getting UI into your game. People use it for things like contracts, people use it for settings, and people use it for menus and level choosing screens. It works really well for this. We're also seeing some less traditional uses of XAML in games. People are starting to use XAML to host videos for things like cutscenes and for level loading. People are using XAML to host video for advertising as well. Video ads are a really large driver for revenue as ads go, and so this is a pretty powerful helper in that sense. We've made a number of improvements in how XAML works for game developers. I want to highlight a couple of these for you. First, there's Swap Chain Panel. Swap Chain Panel is a new XAML element in Windows 8.1. It works a lot like Swap Chain Background Panel from Windows 8. The key difference is Swap Chain Panel can be composed into your XAML like any other XAML element. There are no airspace issues, and it doesn't have to always be the background element in your scene. We've also added a feature called independent input. Independent input allows you to process input from touch, pen, and mouse on a separate thread so that you can reduce latency. And we all know that reducing latency is a really important thing in terms of building a great experience for a touch game. Finally, we've made a ton of improvements in Visual Studio for graphics developers. We've improved performance and reliability by building our high-performance Warp software rasterizer into the debugging experience in Visual Studio. We've enabled developers to do remote graphics debugging on ARM devices. So rather than just capturing a log, you can connect your ARM device to your x86 PC and debug through that connection. We can capture and play back D3D events on different devices. So you can take a capture on a device of a bug. You can capture what happened at the D3D level, and then play that back on a dev machine to understand what happened and to debug the issue. And the best thing is, all of these new features are available in Visual Studio Express 2013 for Windows 8.1. So if you're one of the people who doesn't have the Pro SKU yet, you can still use it. So we've talked about a lot today. We've improved the platform in some really big ways. And the opportunity for game developers on Windows is really better than ever. And we're excited to see you get in on the ground floor before the elevator goes up. So bring your game. If you've already got a game in the Windows Store, thank you. We really love it. But it's time to bring that game to 8.1. It's time to do the update. This should be a really straightforward process for you. You install the new tools, import your project, compile, run the certification kit, and then take a look at the platform features to leverage. If you're building PC games on the desktop, we've made the path to bringing those games to the Windows Store easier than ever. Things like runtime compilation and larger package sizes really smooth out the path to bringing those games to the Windows Store. And finally, if you run into any speed bumps along the way, definitely let us know. We've received a ton of great feedback since we launched Windows 8, and we really use that feedback to drive the development experience forward, and we're excited to keep improving. Now, we've got a ton of great content here at the show for game developers, and of course, we'll be around to answer questions in office hours. Thank you so much.